G4C. Interference to consumer electronics, grounding and bonding. G4C01B. Which of the following might be useful in reducing RF interference to audio frequency circuits? A. Bypass inductor. B. Bypass capacitor. C. Forward bias diode. D. Reverse bias diode. G4C02C. Which of the following could be a cause of interference covering a wide range of frequencies? A. Not using a balun or line isolator to feed balanced antennas. B. Lack of rectification of the transmitter's signal in power conductors. C. Arcing at a poor electrical connection. D. Using a balun to feed an unbalanced antenna. G4C03C. What sound is heard from an audio device experiencing RF interference from a single sideband phone? Transmitter? A. A steady hum whenever the transmitter is on the air. B. On and off humming or clicking. C. Distorted speech. D. Clearly audible speech. G4C04. A. What sound is heard from an audio device experiencing RF interference from a CW transmitter? A. On and off humming or clicking. B. A CW signal at a nearly pure audio frequency. C. A chirpy CW signal. D. Severely distorted audio. G4C05D. What is a possible cause of high voltages that produce RF burns? A. Flat braid rather than round wire has been used for the ground wire. B. Insulated wire has been used for the ground wire. C. The ground rod is resonant. D. The ground wire has high impedance on that frequency. G4C06C. What is a possible effect of a resonant ground connection? A. Overheating of ground straps. B. Corrosion of the ground rod. C. High RF voltages on the enclosures of station equipment. D. A ground loop. G4C07. A. Why should solder joints not be used in lightning protection ground connections? A. A solder joint will likely be destroyed by the heat of a lightning strike. B. Solder flux will prevent a low conductivity connection. C. Solder has too high a dielectric constant to provide adequate lightning protection. D. All these choices are correct. G4C08. A. Which of the following would reduce RF interference caused by common mode current on an audio cable? A. Place a ferrite choke on the cable. B. Connect the center conductor to the shield of all cables to short-circuit the RFI signal. C. Ground the center conductor of the audio cable, causing the interference. D. Add an additional insulating jacket to the cable. G4C09D. How can the effects of ground loops be minimized? A. Connect all ground conductors in series. B. Connect the AC neutral conductor to the ground wire. C. Avoid using lock washers and star washers when making ground connections. D. Bond equipment enclosures together. G4C10. A. What could be a symptom caused by a ground loop in your station's audio connections? A. You receive reports of hum on your station's transmitted signal. B. The SWR reading for one or more antennas is suddenly very high. C. An item of station equipment starts to draw excessive amounts of current. D. You receive reports of harmonic interference from your station. G4C11C. What technique helps to minimize RF hot spots in an amateur station? A. Building all equipment in a metal enclosure. B. Using surge suppressor power outlets. C. Bonding all equipment enclosures together. D. Placing low-pass filters on all feed lines. G4C12D. Why must all metal enclosures of station equipment be grounded? A. It prevents a blown fuse in the event of an internal short circuit. B. It prevents signal overload. C. It ensures that the neutral wire is grounded. D. It ensures that hazardous voltages cannot appear on the chassis.